Okay, good afternoon. So we're switching gears now, talking about the business case and specifically the business case for providing power and other commercial infrastructure services, propellant production. So it's important to talk about the business case so that we can understand what some of the challenges are. Maybe we can try to address them as a group, as a community, and also to discuss the benefits of having commercial services on the lunar surface. It's been talked about earlier that would benefit everyone. That would hopefully lower the cost of conducting missions, as well as reducing the complexity of the missions. So we'll discuss that, and then we'll discuss as well the important factors when analyzing the business case. So some of the factors are production costs, operation costs, pricing, investments, revenue stream, return on investment. So I have here a panel of experts to discuss the business case. All of them have a lot of experience in not only technology development, but as well as running businesses. And specifically, all of them are working on business plans for providing services on the lunar surface. So we'll dive right into it. I'll have the panel members introduce themselves. But I have two groups of questions up here. One is for the providers of power services, those that who see themselves as providing power in the future. And then the second set of questions is for the folks that see themselves as consumers of power. So we'll start with the folks that see themselves as power providers. So the questions to them would be, what power service are you planning to provide? What is the TRL of the power technology you're planning to use? And how do you plan to raise your TRL? And what are the major challenges for closing your business case? So I think Dennis Wingo is a future power provider, so you can introduce yourself and help answer the question.
Hi, Dennis Wingo, CEO of Spectrum Incorporated, with a very long time limited. Along with some of my friends out there who are nodding their heads.
Could not find it?
Do you want to go ahead, Allison, go ahead and answer the question now, or just pass it on?
Oh, you could go ahead and answer the question.
Well, the issue is, and this is something I've asked in the questions before to the power group, is that we are vastly underestimating the amount of power we need for any kind of substantial facility on the moon. And there's a huge difference between if I'm a sorting mission, doing some science, running a few instruments, versus something that the past two presidents have said, or a couple of the presidents' vision for space exploration, and the current one, that we want humans to be permanently there, and we want this to be the beginning of our expansion into the solar system. And I related earlier in 2009, 2010, we built a trailer. We built a 40-foot long, 20,000-pound trailer that we used at Desert Raft for providing power, providing comms. We provided power to recharge the NASA lunar exploration vehicle or surface exploration vehicle. And that was 16 kilowatts, and they had to charge it over 8 hours so that they could drive it for 8 hours. So that's a lot of power. And so we have to, as my friend Alex just said a few minutes ago, is that we need to create a power-rich environment. So we designed what we call a power lander. It's about 100 kilowatts of landed power, and this is with the Blue Origin class lander that they have just announced that we can add our payload to operate in the polar regions. We think, because in business, if you're able to do anything, it's lowering your cost so that you can increase the value provided to your customers. So if you have that, if you have a system, and this is why we advocate, someone asked earlier today, why the polar regions for science? Well, if you're running solar power, which is the only thing you're going to be able to do in the near term, we love kilopower, but if we want substantial power, it's going to be solar. And the fraction is the difference between equatorial region. It's about 23, 24 kilowatts in the equatorial region versus 67 to 70 kilowatts lunation average, which is our monthly average power. that is hugely significant with exactly the same kind of hardware. So these are the things that we look at, and we want to be able to provide power. We want to be able to, because if you're going to do ISRU, I don't care if you're processing water, if you want to derive oxygen from the regolith, it's going to take a lot of energy, a lot more than what people are saying. So if we're going to do that, we need to look at it now, look beyond just the science requirements, and then come up with solutions that can then be offered to other people who want to do their things. And things like what Alex Ignatius had with his storage looks extremely interesting. And these are the kinds of things that we look at because we want to provide value so that not only we, but our customers can make money.
Yeah, okay, Dennis Koulos?
Thank you, Allison. I appreciate the opportunity to be here. So, just for those of you who don't know me, I'm the jack of all trades, master of none. I started out in the Navy. I've flown airplanes. I worked at Northrop Grumman. I managed DARPA programs. I do rockets. I do all sorts of stuff. And I have been dedicated for the last since 1975 or so. I've been a dedicated lunatic also. And also a dedicated space solar power guy. So yes, I belong to the religion of space solar power.
That's what turned you very wide.
Yeah. The moon is a phenomenal opportunity. And the commercial guys are looking at it hopefully as a phenomenal opportunity. You can take a look, and if we treat the moon like it is the Lewis and Clark expedition, and that's all we're going to do, the commercial guys aren't going to be there, they don't care. You got to realize that after Lewis and Clark, what really happened to open the West was the gold rush and people looking for a place to grow food. And that's what made the commercial opportunities exist out there. And so yes, I agree with Clive, we're talking about large amounts of power, and we're talking about global power throughout the entire lunar region. The problem is, I've been hearing today all of the discussions, not just local power, but micro-local. We need to have power at a rover, at a sensor, and that the commercial guys don't care. You guys have been solving that problem for a very long time, and you don't care. But when you start talking about having global power to support human exploration and colonization, now we're talking about something that the commercial guys are going to be interested in. And what this gets to answer part of your question there, is what are they really looking for to get the commercial guys interested? George did a phenomenal thing a few years ago in that he was the first one to say, we'll pay this much money for rocket fuel that you mine off the moon. Nobody had ever put a price point there before. For the power guys, I have looked for 15 years and I can't get this is the price point for a kilowatt of power on the moon. And I can't go talk to an investor until I know what that number is. So that's one of the things that has to happen before you can ever expect the commercial guys to give you a hand in trying to figure out how to do the moon. And as we've all heard the implications, we had Apollo, then we had the first Bush, then we had the second Bush, then we had Obama with, we're not going to do what the previous two guys did, and now we've got another guy and we're changing all that again. Okay, so NASA, for a commercial perspective, is a terrible customer. It lasts no more than 4 years, so we need some stability in the marketplace itself. I think that kind of sort of answers your first two questions, what are my perspectives. And oh, by the way, just so everybody knows, the thing that I have been pushing and working the longest, and I'd be more than happy to talk to anybody about, is wireless power, which has a TRL of infinity, because God's been doing it for the last, I don't know, since time began. So we know that it works, and I do it optically, and it has a billion %, there's a significant number of effectiveness issues that improve the capability of it, and you could do it globally, and you do it from space in orbit around the moon. And so I can provide power anywhere on the moon, specifically at the polar regions, and you can do it continuously, reliably, and it's something that we know how to do. Okay, so
What is the range of the power you're talking about?
it strictly depends upon how much power you want. If you want 100 kilowatts, we can put up a set of solar panels in lunar orbit, and we can transmit that power down. And by the way, the enabling technology is not solar panels. Solar panels are terrible. There is work going on today that is called power by fiber, and it's specifically designed for monochromatic laser, and we're reaching efficiencies demonstrated well over 40%, and they have some in the laboratory that are demonstrating efficiencies as high as 68, almost 70%. And by the way, the efficiency just says that you've got waste heat, and isn't that a wonderful thing to have in the dark polar regions? You've got a lot of waste heat that you can use to keep your little vehicle running around and keep it warm. So I can make as much power as you want just by putting up more panels.
I wanted to go down to Mohammed and Rolf, since I wanted to separate the power providers discussion and we'll get to you, George, for the power user. So Mohammed, you can...
Thank you, Aaron. So, I'm Mohammed Ragab. I work for iSpace. I've started working for iSpace a couple of years ago, and I joined to start a blender development. A little bit of my background. After getting my doctorate from France, I came to the United States. I worked on aircraft development first. And I went into launch vehicles. I worked on launch vehicles for a long time. And then I went to iSpace, started working on that. About iSpace, it started with rover only. They were going to compete with the Lunar X Prize. And then iSpace realized that it's not prudent to rely on other people providing them transportation to the moon. So that's where they started their development. They are not about transportation only. They are about wanting to have a moon valley in 2040. So they are about having a cislunar economy that stays. But in the beginning, what we're doing now is developing a lander, and we have the rover, and we're gonna, enhance the rover before flying it. In terms of what we can provide, so our plan is to use existing technology. So we start with the solar panels and standard batteries and so forth. The rover has been designed very efficient. Uses the solar panels at an inclination that depends on the location on the moon that it's going to. That is our current technology. We would have to grow if we're going to provide more significant power and try to stay through the night. We would have to grow our lander. Our lander currently has a payload of 50 kilograms. We have to grow that if there is a bigger need. So that's where we are.
Could I just ask a follow-up question, Mohammed? So you said your plans are to provide power. Do you have a range of power that you're planning to provide and a time frame, and when do you think that would be available?
So what we're thinking is providing power to our own payloads, like rovers, and we can do that once we start flying. We could fly a couple of rovers, for example. If they are the mass is about maybe 10 kilograms or over. We can fly a couple of rovers, and we can provide that power.
And then that would be sufficient power to survive the lunar night?
If we do hibernation, so you have to observe the heat. In Japan, one of our employees had worked on an experiment that JAXA did to determine how much they can conserve heat by essentially putting up to 10 and it was feasible. But we'd have to design that. We'd have to design a way, as somebody mentioned a little while ago, we have to change configuration essentially. So after landing, when the night comes, you have to cover yourself with the MLI, and try to conserve it. If you have enough battery, you can survive.
Okay, good. Okay, Ralph?
Yes, hello everybody. My name is Rolf Erben, representing heating scientists, headquartered in Berlin, but also with a subsidiary in Houston, where I'm at very often. So my background is, I grew up in German Aerospace Agency and ESA. But as a dual citizen, I also worked at the Johnson Space Center as a flight controller for over 11 years. And somebody was mentioning earlier the second Bush coming in, so in 2012 constellation happening. I was working lunar lander and constellation spacesuit system. So so where are we today? So this company headquartered in Berlin, we too are developing a lunar lander. Obviously it's a key piece of infrastructure and missing link. And the way PTS started out, I wasn't part of it, and it's their first major partner, other than the space agencies, was Audi, so a big car manufacturer. And I'm saying sponsor, that's not true, because they're really a technical partner. So they were heavily involved in the design of the vehicles. So of course they don't have space knowledge, so that came from DLR for the thermal vacuum testing. The rovers, as complex a lunar rover can be, of course, it's not the complexity of the lander. So we're working the lander. So the rovers can be, but they don't have to be part of the entire architecture. Obviously, we're planning several missions. First one with the rovers, but then there's so many scenarios out there. So what's really elating is that we do have a lot of customers from outside the space agencies who are really interested in getting involved. And some of them experts as far as power, thermal questions go, and some of them not. So we have to basically sometimes hold their horses and explain to them that it's a lot of factors involved in flying a mission, like where you land, what is your ability going to be to generate power. I mean, we are heavily relying on solar power, so yes, there are future outlooks, but certainly our ability to recharge the batteries at the angles we're going to be able to get. And so I mean, you are expert, so I don't have to explain that. But what is kind of interesting is, so most of the folks here have some space agency background or have been working with them. So a lot of our customers really, they don't know anything, but they do want to be involved. So that's great. There is truly a market evolving, and I can attest to that. I mean, I'm sure it's true for other companies on the commercial side also. So it's not the same old people, or companies or agencies involved. It's very fresh folks, fresh money. That's important. So you're not dependent to be sitting on one pillar of money supply, right? I mean, it's great to receive government money, but it's just better to have a mix of funds. So if whatever funds dry up, you still can progress. So I'll leave it at that. Just hand on to the next person.
Well, I wanted to follow up on Rafa. And I did ask what do you think is the major challenge for closing your business case?
Closing the business case. Closing the business. I mean, really, you hear that over and over. Also, when we talk to investors, the business case, there's really so many angles in a business case. So, I mean, to give you the best example, let's say some billionaire is there and he knows nothing. But that's your business case, right? He realizes when he dies and the coffin doesn't have any shelves, right? I mean, he can't take it with him. So that's your business case right there. Somebody helping somebody still to do something useful with his money in his lifetime. That's the easiest case, right? But then it gets very complicated. Like some investors, they have very specific technical conceptions what they want to do on the moon. So, and it's very different also what we originally thought. So, just like every head in this room has a different perception of what the future on the moon is going to be like. And earlier it was mentioned, well, how the West was won. Well, nobody back then knew exactly how this is all going to pan out. It's once you bring that infrastructure in place, and there's no golden path how to do that. It's just there will be one new technology tipping off a whole spectrum of others, and that's how it's going to go, and it's going to go from there. I mean, the sure thing is it is happening, and this is actually the time where it is happening. I'm totally confident. So, business case, we have so many people who already are partners, who want to become partners, either technical partners or investment partners, or sometimes it's just advertising. There's a whole spectrum of business cases. So, and so far, I mean, obviously more is better, but we're not struggling, so that's good.
Okay, thanks. That's George.
Yep, hang on, before you go to
go
George,
ahead,
Dennis sparked something. We would sell power on the lunar surface for no more than $100 to $150 dollars per kilowatt hour. And to compare that on the Earth, in the United States military is paying $30 a kilowatt hour in Afghanistan. So that's only 5 times more than what we're paying for on Earth in a remote situation.
Okay, I think a lot of you know me. I'm George Sowers. I'm currently with Colorado School of Mines, where we had launched the world's first graduate program in space resources. So if you're interested in a graduate degree, talk to me or Anel. Before that, I was 30 years in the aerospace industry in the rocket business. I retired from the United Launch Alliance about 1.5 years ago. And as Dennis mentioned, we spent a lot of time thinking about propellant, in particular liquid oxygen, liquid hydrogen propellants, which you can get from water. Because United Launch Alliance, at the time I left, was developing stages that could be fully reused if they could be refueled. And so if you have those, then the next thing you're looking for is a source of fuel. And we actually, as Dennis mentioned a couple of years ago, stood in front of the space mining community and offered to buy propellant for certain prices. It was sort of transformational, I think, to that industry, to suddenly have a customer. Because if you want to have a viable business, and all of you aspiring entrepreneurs, write this down, your revenues should exceed your costs. It's that simple, and that's what it needs to have a business case, and Allison's already put that up there. So we looked at the problem of propellant from both sides. ULA had a demand for propellant that was based on moving satellites from low Earth orbit to geosynchronous orbit, which is an existing market. It wasn't, we didn't want to jump in and build fictitious markets, because then those markets have to materialize before you can do anything. When I got to Colorado School of Mines, that's the revenue side of it. So ULA is willing to buy, and it shows it on the left-hand column only, the commercial only, 1,100 metric tons of propellant on the surface, delivering on the surface of the moon for $500 a kilogram. That was the prices we set a couple of years ago. Those need to exceed the cost. So the question becomes, can you produce propellant on the moon for $500 a kilogram or less? If you can, you meet the first criteria of having a viable business. We did some architecture studies at the School of Mines and came up with some interesting approaches and estimated some costs. And as it turns out, $2.5 billion, $1.5 billion for hardware development and production costs, and $1 billion to get it to the moon and then place it. And that actually generates an internal rate of return of 9%. So that's a fancy way of saying revenues exceed costs, even when you discount those based on time. We also took a look at a public-private partnership, because having one customer is great, having 2 customers even better. NASA in the ISRU BAA that came out last year stated a provisional need of 100 tons of propellant per year on the surface of the moon, and this is to get vehicles off the moon and up to the gateway and back. We added that into the demand side of the model, scaled up the production to meet that, and assume that NASA would be willing to invest $800 million in the development of this system for propellant. 800 million was kind of pulled out of the air, but it's commensurate with what NASA invested in the COTS program, you know, for ISS services, cargo services. And lo and behold, that pops the internal rate of return up to around 16%, which is starting to approach the threshold where, you know, venture capitalists or other kinds of investors would be interested. 9% is positive, but it's kind of marginal given the risk. You'd love 9% on your bank account, but if you're risking your investment on the moon, that's probably not enough. So then you ask yourself, what would, okay, so this gives you the cash flows. This is basically just the cumulative amount of money that's going in and out of your bank account. And sadly, most aerospace ventures look like this. There's a huge, all the investment comes up front, and then you're hoping, you know, down the road to make money back. And you can see the difference between the commercial only and the commercial plus NASA business cases. Obviously, it's much better if NASA jumps in and participates. But these kinds of cash flow curves are very typical in the mining industry or the oil and gas industry, where you have a lot of investment up front and you're counting on revenue streams over a long period of time on the back end. The difference between something like this and the traditional mining industry or oil and gas industry is that they know their markets very well. They understand the commodity markets, they understand their costs very well. So, you know, the key thing in getting something like this off the ground is to buy down the risks so the conservative investors in the mining industry and oil and gas industry could step in. You know, why would NASA want to invest? If they had to deliver all that propellant from Earth to the surface of the moon for their asset, like we did in Apollo, rough numbers, $35,000 a kilogram, it would cost them $3.5 billion per year to do that. At $500 a kilogram, they could buy that propellant on the surface of the moon from a commercial company for $50 million. That's $2.5 billion savings just in that first year, including the $800 million initial investment. Just for grins, I calculated the internal rate of return on that. 80%. That's an annual rate of return to the taxpayer. Pretty outstanding. If somebody from NASA, you know, is listening, you may want to start thinking about stuff like this. And just to kind of give you an idea what the architecture would look like, my current favorite crater is Shoemaker. Looks like there's a lot of ice there, but you know, we were using reflected sunlight as the power source. Giant heliostats up there, reflecting down. You know, it's powering an electrolysis plant and purification plant, but it's also using sunlight to directly heat the surface of the moon to sublimate vapor, to capture in that sort of dome-like structure that you see in the front there. So business cases do exist and can close for the moon.
Okay, thank you. I think now we can open it up to Q&A from the audience.
George, Alex, and that's if this works. So did you include the cost of energy, and how did you get the energy to do that process?
So
That's electrolysis, it's expensive.
yeah, so the sunlight's doing two jobs. One is directly sublimating the ice from the surface. The other job is powering some photovoltaics to do the electrolysis. And just to emphasize Dennis's point, you know, the power plant or the propellant production plant that we estimated was on the order of 2.5 megawatts power supply required.
And so that's not in your number because
That is in the numbers.
it doesn't compute. Well, we can talk offline, but
So the masses of those heliostats was part of our analysis.
But if you're talking about 2.5 megawatts of solar to launch to the moon and in placing, that's a very significant number. I don't see it in there, but we can talk about it.
Yeah, so 29 tons was the total mass of our system.
We'll check.
Jeff Van Cleve of Ball Aerospace again. You spoke of the moon as if it were a single place, so you're going to generate propellant in some place. But NASA may not necessarily need those 100 tons of propellant at that place. They might want it at the poles, the far side, some other place. How do you incorporate that twist in your economic case? Because then there's a transportation cost to get fuel from one place on the moon where it's made to where it's needed.
Yeah, I mean, that would have to be accounted for in NASA's cost. So, you know, the propellant production that we talked about here would be, you know, the delivery point would be at within the PSR that you're mining. So if you want it somewhere else, you gotta transport it somewhere else.
Well, that sounds like an interesting little study in itself. Thank you.
Yeah, I mean, you know, ULA was transporting it from there to low Earth orbit.
Go ahead, question.
There's 4 other people on the panel.
Some of you mentioned wanting one big customer, talking about a big facility, but some of the things that we need to do, not just for the science community, but for reconnaissance, distributed network would be a very good idea. So the question I have for you is, considering a model of distributed customers, which can still look at the power grids and the wireless communication models can provide services for a wide number of customers, how do you see that twist in your model in terms of providing a lot but having it distributed?
Yeah, specifically, that's what I'm interested in. You could put the nuclear stuff down in one place, and you could sort of operate from there if you want to hang on the Schumacher crater rim. But I don't think that's what we want to do. I think we want to be able to rove around and do things in different places. And by providing the energy from orbit with the ability to see a lot of different places, you can use fast streamer and a lot of different things. And you can sit down and support a number of customers. I don't want one customer. I want 500 customers. I want 1,000 customers. Like I said, NASA's a great bunch of people, but it's one customer and they can go away in a hurry. And I'm looking at business. So that's the kind of thing where, yes, you want to be able to distribute it. By the way, modulating that optical signal, you can get communication. So Dennis and Jay Penn and I were sitting around at John Makin's Fresh Look study many, many years ago. And Dennis said, power is interesting, but if you modulate that signal, that's where you can really make money. And so yes, it also provides wireless communications. And you can do both with one thing.
Yeah, and one thing the science community could actually think about is take a look at all the rovers. Opportunity just died because its solar panels got covered up in the dust storm. And you have these the rovers, whether it's the moon, Mars, there's only so much solar array you can carry, which limits your mobility, which limits your science payload. Think about if you could offload that problem to a provider. In my case, I was sitting thinking about it, $100 or $150 a kilowatt hour. And if you needed 10 kilowatts, there it is. If you need 50 kilowatts, there it is. And so that starts you to change how you think about the design of your rovers, your science payloads, your experiments, because you're not having to always build an integrated system. You're able to focus more on the payload. You're able to focus more on what you want to do. And in our case, what we did at Desert Rats, we had a trailer out there, and we had a NASA Ames rover. And we had Pete Wharton in his office at Ames operating the rover, so we had power and communications. And then that rover could come back, and we later developed an autonomous charging system. That rover could go off and do its thing. It was much faster than the opportunity at 3 millimeters a second. It could go off a kilometer, do its thing, come back, charge up, be under our tent, so it could survive the night, have a nice little heater under that.
When Bigelow goes and builds a hotel, he does not reinvent a communication system, he does not reinvent power, he does not go out and build a Hoover Dam or a nuclear reactor. He buys it commercially. Power and communication should be a commercial thing. The buy, and you have a standardized set of protocols, and it's something you put on the rover, and it's there, and it's done, and you never have to reinvent it again.
Absolutely. We had to solve that for space station and the external utility port. I was told with a straight face that no, there is no such thing as a standard utility port. There won't be for station. It should be custom designed power supplies for everything that's put on board. I told them that's not how you build a facility, and we were able to make it stick. We've got some options for us going forward here.
Okay, next question, Alex.
I'm back. So I'm a believer in power being. I agree it's the way to go. However, in terms of distribution of energy on the moon, electrical energy, it's actually much more direct. You don't have to worry about wires, you make the wires. In terms of the process of the regolith, where we extract silicon for our silicon solar cell, byproducts turn out to be things like aluminum, calcium, magnesium. All of those good conductors on the moon are perfect because there's no atmosphere to contaminate them. You can make essentially thick film conducting wires on the surface of the moon simply by plating the moon with things like aluminum or calcium, and then feed your electricity down there.
In the near term, though, if you're trying to get rovers to go do prospecting inside the dark craters, you can either put a battery on there and try to make them operate for a while, or you could beam them power from one of the crater rims, and you can do that over a distance of 50 miles, and they can continuously operate, not come back and get recharged and recharged and recharged.
I agree. You're right.
Okay, any more questions? I have one last one related to some of the questions that Andy put together for the workshop. So we're trying to gather information to NASA to make informed decisions. So this was good to talk about the commercially available power. So I've heard that it's going to be off in the distance. So would it accelerate some of the development, some of the business cases that we're talking about if the companies were to engage in public-private partnerships with NASA?
Every time I talk to an investor or try to get somebody, one of those billionaires that just wants to throw money at something, first words out of their mouth are, is there a customer, and when is the customer going to need it? And it's the same thing that Mike Griffin and I talk about. Until there is a confirmed customer that says we're going to do this, you're not going to get any of these systems built. And that gets to the point where NASA just needs to sit down at some point and say, in 7 years, we're not going to do power on our systems anymore. We're going to buy it as a commercial entity. At that point, you will have providers showing up, knocking on your door. There's 1,000 different ways to do it, and they will be there. But until that time, until they know that there is a customer, they're not going to make the investment.
Yeah, I want to shade a little bit different on that. I think it's above NASA's pay grade in this regard. And I look at what China's doing with their Belt and Road Initiative. The Chinese government has decided that they want to own the terrestrial transportation infrastructure across most of this planet. And the Chinese government has invested hundreds of billions of dollars in this, and people use that infrastructure. It's my understanding that they're looking to do something similar to that on the moon. And if you look back in American history, the Pacific Railway Act of 1862 provided a means. We built the first railroad across the American continent, with the United States government putting up the capital and allowing companies to sell bonds against that capital being provided on a milestone basis. And so regardless of what NASA itself has a need for, if the United States government decides, and SPD-1 is actually a very good document for this, but we do not have the advocacy of this at NASA right now. This is more the National Space Council. If you talk to Scott Pace, if you talk to the Vice President, and people like that, they want to do stuff like this. There is actually a disconnect at NASA because NASA, and I don't want to say it this way because it might sound pejorative, it's the NSF of space. All of your missions are driven by science. All of the science is driven by the decadals. All the decadals are driven by the science who want to do the science in the next decade. There is no equivalent commercial decadals. So it has to be above NASA's pay grade as a national decision to spend this money, to make this money available, like in a federal financing bank or something like this, to put forth the capital that allow people to build this type of infrastructure, and then NASA as a science agency, the Defense Department as the Defense Department, and whoever in commercial can then use that infrastructure. That's how we built the National Railroad, and nobody in the world figured in 1868 when that railroad was finished that by 1875 the San Joaquin Valley would be the fruit basket of America, and it couldn't be that until that infrastructure was built.
Anybody else wants to add? Bob?
Yeah, what you just mentioned is these NASA private partnerships. I mean, we know CLIPS is out there. I think that's extremely vital. It's extremely vital. It allows these companies to generate completely different revenue because of these partnerships. So they function like a catalytic catalyst, right? So with every government dollar you can make, I don't want to put a number out there, but it is very important. It gives confidence for the investors. So what NASA is doing, also other space agencies, ESA is doing right now, I mean, the concept of the Lunar Village, whatever that is, let's not go into that. So it is very important. And it's also very important to create many companies working on this, so you have dissimilar redundancy. I mean, who knows which factor is actually going to make one company successful, which another company doesn't, and they can or cannot join forces. So I think it's a key thing, a key question you just asked. The other thing is, I know it's possible from a physics perspective, of course, to supply power from orbit. I wouldn't be the expert. I don't know what the TR levels are. I do understand the communication is much, much better. And we have engineers in our company who are actually working that also with other industry partners. Another $1 million or $1 billion company, Vodafone. So our concept to provide communication between the rovers and the lander, it's pretty much taking off-the-shelf technologies, making them space-worthy. But as we all know, if we did have the assets in lunar orbit, that we could all just buy these services, right? That would be very important for all companies. I mean, yes, you can go up there and just, before you descend, deploy your own relay satellite. But do you want to depend on that? No, you don't. You want to have something up and running which is reliable. So for data, for telemetry, and of course, I mean, we all know how vital it would be to have huge data rates being available through deep space networks, relying on laser communication terminals or things like that. So closing the business case, yes. Having space agencies say, yes, we support this, this is where we're going. It's a huge deal, it's a huge symbolism. I mean, whatever happens there on a detailed technical level is secondary. It's really secondary. And the other thing is there are certain technologies which make a lot of sense to help establish them. So that's the role of the space agencies to help making sure that these technologies get established. All right.
I want to throw a question out to the audience. Who all here has some connection, however tenuous in the past or in the present, to Stanford University? Hold up your hand. In this audience, not many Stanford folks? Okay.
I can't put my hand up here.
Yeah. Well, none of you would have that connection without the Pacific Railway Act of 1862.
One of the things that I actually do, I'm Jack of all trades, master of none. One of the things I actually do is I'm a translator. I'm enough of an engineer that I can talk engineer to the engineers. I'm enough of a manager I can talk management to management. They don't know that I'm not good at either one of them, so I kind of fool my way around. Let me translate public-private partnerships for just a minute to a lot of the NASA guys here. Okay, the NASA guys see the private guys bringing in 85% of the money, NASA providing 15% of it, and then using the resources. And that's not bad, that's a good idea. The public guys, the commercial guys, see the government providing 85% of the money, and then providing 15% of it, and then using it commercially. So every time you use that PP word, you need to know which guy you're talking to, because I guarantee you there is a complete mismatch of thoughts on that. And I know, because I'm working with a guy right now, and he is a commercial guy, he's never done anything government, never done anything space, and the guy is insistent that the government's going to give him 85% of the money to do this, and I just keep telling him.
Yeah, I mean, both sides have to look at a PPP as a business deal. It's got to be good for the government, it's got to be good for the private guy. It's not, it can't be one way or the other. I was part of companies that participated in the EELD program back in the late 90s. Ended up being a great deal for the government, a terrible deal for the companies. Lost their money. So we have to learn those lessons. But to go back to Dennis's point, I think the SPD1 has some great words in there. One of which is we're going back to the moon in part, and I'm paraphrasing, for economic development. And we need to start recognizing that economic development is one of the purposes for going into space. It's not in NASA's mission statement right now. It's science and exploration and other things like that. Economic development now has made it into the nation's policy at the highest level. SPD2 assigns the role of the Commerce Department to do something. I mean, it's a little vague, but it's kind of nice that they're getting the Commerce Department involved. And I think those are all great advances. What we need to figure out from a NASA perspective is what's NASA's role in all of that.
Oh, are we running out of time?
I think that's.
Oh, go ahead, last comment, go ahead.
I was just going to say, yeah, just one last comment. If you look at historically what governments do, governments provide infrastructure so that commercial entities can go ahead and operate and do things. And NASA doesn't think in those terms. NASA, from a commercial side, what I'd really like to see, like to see NASA build a port where we can come and land and then drive off and go do things. And NASA provides medical resources and other, it provides all the things you have in any kind of port. I'm a Navy guy, okay? Governments run ports. Governments make roads. That's what they do. And I think that's SPD2 is along those lines of the government's role should now be re-evaluated and move forward into the future to provide a commercial basis to be able to do things on the moon.
Okay, well, thank you. Let's thank the panel members for their participation.